All right, everybody, hello and welcome back. Today we're going to do is we are going to work on solving radical equations and equations with rational exponents. So those two things kind of go hand in hand because if we keep in mind, we can rewrite radicals as rational exponents and vice versa. All right, so therefore the solving method that we are going to use, or methods, they're going to be about the same. The only difference is how our rational exponent is going to be represented. So our steps in solving these problems are going to be, first of all, we want to isolate our value. We want to isolate either our radical or we want to isolate the exponent. That means we want to move everything away from it and onto the other side of our equal sign in order to get that x value by itself. So we're going to isolate that first, and then our second step is going to be to undo the radical or undo the rational exponent. All right, that will allow us to get towards our variable, and then we can do our real last solving step, which is to solve. We are going to eventually get that variable by itself, and I'm going to add an extra thing down here, and it is our last step that we're going to have to check our solutions. All right, sometimes when we are solving these types of equations, the methods we use to solve lead us to getting extra solutions that might not actually work. Those are called extraneous solutions, and we'll take a look at that a little bit later on. So the first problem we're going to do is the cube root of 2x plus 4 is equal to 2. Now, the one thing we want to keep in mind is that a cube root is the same thing as having an exponent of 1/3. So what we want to do is think about, okay, what can we do to this side to get rid of that 1/3 in our exponent? Well, in order to get inside the parentheses, we need to get rid of them. And to get rid of our parentheses, we need our exponent to be 1. So we need to start to think about, okay, what can I do to 1/3 to get it equal to 1? Well, if we follow our steps over here on the side, we need to isolate. Well, luckily for us, this radical is already by itself. There is nothing else other than the values underneath the radical on the left side of our equation. So all we have to do is then undo the radical. And thinking back up here, thinking back to the idea that our cube root is really an exponent of 1/3, what we are going to do is we are going to raise that side to the third power. Now what's going to happen is up top, if we look at that rewritten version, when we have 1/3 and 3 in our exponents, these are going to multiply and essentially they're going to cancel each other out because they are reciprocals. 1/3 times 3 is going to give us 1. What that will allow is our radical and our exponent to cancel, and we will be left with 2x plus 4. Now if we do something to one side, we're going to have to do it to the other. So I'm going to cube 2. 2 to the third power is going to give us 8. And now that we undid our radical, we can now solve. So I'm going to subtract 4 from both sides to get 2x equals 4. And then I'm going to continue to use inverse operations to isolate that value and get x equals 2 as our solution. Now that last step that I added in there is a check. So let's plug back in and double check that this is going to work out the way that we think it's going to. So if I plug that in and we take the cube root, this should equal 2, right? That's what our initial equation here says. So I have 2 times 2, which is 4. 4 plus 4 is 8. And then the cube root of 8 is in fact 2, so this checks out. That tells us that 2 is the solution to this equation. Now, we might have slightly more complicated equations, just like this. And this is when that check at the end is going to be very important. So our first step is to isolate. And again, we don't really need to isolate anything here because our radical is by itself. All right, now let's just pretend we had a plus 4 over here. Well, that would be something we would need to isolate. We need to move over to the other side. I would need to subtract the 4 over in order to get my radical by itself. But again, in this problem, we don't have that concern, so we're just going to go ahead and solve. All right, so in order to do this, I need to, again, get inside that radical. That square root is kind of blocking me from being able to manipulate this x value, which I need because there's another one over here. So I isolated the radical, it's already by itself, and now I'm going to undo it. That is a square root, and I can undo a square root with a square in the exponent. So I'm going to square both sides. And then on my right side, the radical and the exponent cancel, and I get 7x plus 15. Now, the left side is going to be a little bit tricky. And the only reason I say that is because a lot of students tend to just distribute that exponent into both the x and the 1. And that doesn't work here. When we have addition on the inside and our exponent is 2, that tells us that there are 2 of these things. And we are actually going to have to FOIL out. So if I do that, I have x and x, which is x squared. X and 1 is a 1x. 1 and x is 1x. And 1 and 1 is 1. So I have x squared plus 1x plus 1x plus 1 is equal to 7x plus 15. And now we can solve. So I isolated, I undid my radical, and now I'm going to solve. So x squared plus 2x plus 1 is going to be equal to 7x plus 15. Now, this is a quadratic, so in order to solve a quadratic, I need to move everything to the same side. So I'm going to subtract 7x and subtract 15. And I will get x squared minus 5x minus 14 is equal to 0. Lastly, I need to think about a method that I can use to solve this quadratic. I personally like to factor. In factoring, we get both solutions at the same time, and there's not usually a whole lot of work that goes into it. However, you are welcome to use the quadratic formula. You could try the square root method, but obviously that wouldn't work because we have 2 separate x values here. So I'm going to factor, and I'm going to try to think of 2 x values that are going to multiply to a negative 14 and add to a negative 5. Now, of course, those numbers are negative 7 and positive 2, so if I plug those in, and again, those orders don't matter, I can then solve this quadratic by setting each one of the factors equal to 0 and solving. So my first solution is x is equal to 7, and I subtract the 2 to get x equals negative 2. So this one's a little bit different because I have 2 solutions. Again, the methods we use to solve sometimes create solutions that are not really solutions. Those are called extraneous solutions. So what I'm going to do is I'm going to have to go up to our original equation, and I'm going to plug each one of these values in one at a time. So I'm going to have 7 plus 1 should be equal to the square root of 7 times 7 plus 15. I get 8 is equal to the square root of 49 plus 15 is 64. And the square root of 64 is 8. And therefore, this checks out. And x equals 7 is a solution. Now I'm just going to do the exact same thing with negative 2. So I get negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. We get negative 1 is equal to the square root of, well, that's negative 14 plus 15 is positive 1. Here's where we have a little bit of an issue. The square root of 1 should be just 1, not negative 1. So that tells us that these two things are not equal, and therefore this didn't work. So therefore, our x equals 2 is an extraneous solution, which means it is not real. So for these problems, if we get multiple solutions, they either could both work, one of them could work, or neither of them can work. That is absolutely an option that might come up. But the key idea is remembering these steps. Isolate the radical, get it by itself. Undo it using exponents. Solve the equation, and once we get our solution, plug it back in to check our work. Now, what we're going to do is we're going to flip over and we're going to try a rational exponent equation. And again, those properties, those rules that we've been using are going to work the same way. So we are going to isolate the exponent by itself. Then we're going to undo the exponent. We are going to solve our equation and check our solution. So I jump back down here. I'm going to first isolate. So this is a perfect example. This is what I'm trying to solve, right? The x values inside those parentheses, and those parentheses have our rational exponent. Well, the 2 is not part of that. So I need to isolate the rational exponent by moving the 2 to the other side. I'm going to use inverse operations to divide by 2. And I will get x plus 3 to the 2/3 power is equal to 9. All right, so now we need to think about what can I do to get rid of my exponent of 2/3. Well, let's flash back to our first problem. Our cube root is the same thing as raising x to the 1/3 power, and so we cubed that. 3 and 1/3 are reciprocals. If we go back to this problem, the square root is the same thing as having an exponent of 1/2, and we raise our values to the second power. 2 and 1/2 are reciprocals. So similarly, I need the reciprocal of 2/3, and that answer, that value, is going to be 3/2. And here's why this is important. A power raised to a power means we need to multiply. When I multiply 2/3 and 3/2, I'm going to get 6/6, which is just 1, which means I no longer need my parentheses. And that is the entire purpose here. Now, I'm going to do the same thing to the other side, because once we do something to one side, we have to do it to the other to keep our equation balanced. And I have 9 to the 3/2 power. There's a couple different ways we could do that. Some of you could just plug this into our calculator, but if we think about what it means, this is really 9 to the 1/2 power raised to the third. What I'm doing is I'm using exponent properties to separate the exponents, and the reason I do that is 9 to the 1/2 power is the same thing as the square root of 9, which is 3. 3 to the third power is 27. Okay, so we could do it on a calculator, but again, in my experience, it is better to be able to do these types of calculations when possible by hand, so we have a better understanding of how our rational exponents are going to work. Lastly, let's just finish and solve. Isolate that variable. I'm going to subtract 3 from both sides, and I will end up with x equals 24 as my solution. So we isolated our isolated our rational exponent. We undid it. We undid that exponent using its reciprocal, and then we solved. Our last step here is going to be to check our work. So over on the side here, I will take my original equation. I'll plug in. So this is something that should end up being equal if 24 is in fact our solution. I get 2 times 27 to the 2/3 is supposed to equal 18. Well, similarly to how we did 9 to the 3/2, we can do 27 to the 2/3. If I separate this to become 27 to the 1/3 squared, that might help us think about this a little bit. 27 to the 1/3 is basically taking the cube root of 27, which is 3. 3 squared is 9. So we get 2 times 9 is equal to 18. And that checks out. 18 is in fact equal to 18. And therefore, x equals 24 is a solution, and it is not extraneous. All right, don't forget to check your work. It always happens where we have students solve. They do a perfect job solving, but then they never check. And so you're basically claiming that another value is a solution when actually it isn't. It is just something that came up using the method that we use to solve that problem, okay? So let's touch base on our steps again. Whether we're solving a radical equation or an equation with rational exponents, the steps should be the same because both of those things are essentially identical, just different forms of each other. We are going to isolate that value. That means get it by itself. If there's anything that is not under the radical or that is not sharing the same exponent, I'm going to move it to the other side of my equal sign. I'm going to get that value by itself. Once we do that, we should have a radical on one side or a rational exponent on one side. We want to undo that using the opposite, so using the inverse. Well, radicals and exponents are going to undo each other. So if you have an exponent, use a radical to get rid of it. If you have a radical, use an exponent to get rid of it. Once we do that, we should be able to finish and solve the problem. And then lastly, go ahead and check your work. Okay? There's a lot of different types of these problems that you might see, so it's a lot for myself or for your teacher to cover. So please make sure that you are just following these steps. All right, it's going to take a little bit of thinking because, again, there's lots of unique situations that might come up, but your steps listed on the side here should always remain the same. Okay? Thank you for listening. If you have any questions or concerns, as always, please feel free to leave a comment below.